One tool we have for analyzing compound truth statements is the truth table. So a truth table lists every possible input for your compound truth statement and then lists the output of that statement along with any intermediate steps. So let's take the truth statement A and B. I have two inputs here. I have A, which takes the truth value, and B, which takes the truth value. So I start off with two columns, a column A and column B. My third column is the compound statement, A and B. So we list every possible combination of truth values. For example, A is true and B is true. A is true and B is false. A is false and B is true. And then finally, A is false and B is false. So now we have all the possible combinations listed. We evaluate the last column, the compound statement A and B. We look first at the first row. We have A is true and B is true. So true and true is true. Now we look at the second row. We have A is true and B is false. So true and false is false. Now we look at the third row. We have false and true, which is false. Finally, we look at the fourth row. We have false and false, which is false. So this is the truth table for the compound expression A and B. So we can see that with the operator AND, we only have one way to make true. That's with two trues, and we have three ways to make false. So on Trinket, you can test this out. If you go to the Trinket, then we can play around with it. So let's set A to true and B to true. And we want it to see what it prints out. I'm using this block AND here, and I have the two variables A and B. When you're making blocks like this, make sure you're using the variables and not making strings that say A and B. So let's see what it prints out. And it is true, just like our truth table said. Let's say I have A true and B false. We would expect it to be false, and it is. And we can check for the opposite, it's also false, and for both false, we again get false. So everything's in good working order. For OR, we can also make a truth table. So if I have A or B, then I have A and B, and then A or B as my last column. So again, we have the same setup of possible combinations: true, 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 false, false, true, and false, false. This time I have true or true. Or it can be both, or it can be one or the other. So this is true. I have true or false. Since we have one true in there, the or statement is true. And then false or true, again we have one true, so it's true. And then false or false, we have no true values in there, so the or is false. So and we were only able to make true one way. With or, we're only able to make false one way, and that's when both of our inputs are false. And you can verify this with Trinket in the same way that we did AND. The NOT table, so if we had NOT A, in this case we only have one input, so we have only one column, and then NOT A for the second one. So A can be either true or false, and then not true is false, and not false is true. So our truth table for not is very similar, or is very simple. The power of truth tables comes in when you have more complex compound truth statements. So let's say we have a compound truth statement that has a negation on one of the variables. So let's say we have not A and B. Again, we only have two truth inputs here. We have A and B. So we have two columns, A and B, for the inputs. This time we have an intermediate column that we want to do, which is not A. And then the final not A, and B. Again, we have the same possibilities for A and B. True, 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 false, false, true, and false, false. This time we want to do the first column, or the not A column first, because the last column will depend on the not A column and not just on the A column. So not A, when A is true, is false. It's just going to be the opposite of whatever A is. So not A for true is false, not A for false is true, and not A for false is true. This time, for the last column, we're going to do it very similar to how we did the AND truth table, but this time we're looking at different columns. For the not A, we will look at the not A column. For the B, we're still going to look at the B column. So we're looking at this red column and the purple column. So for the first row, we have false and true, which is false. For the second row, we have false and false, which is false. For the third row, we have true and true, so we have a true value in here. And for the fourth row, we have true and false, which is false. So this is the truth table for the compound truth statement not A and B. We can verify this truth table using Trinket. So if you go to Trinket, instead of A and B, we want to use the not block on A. So not can be found under logic. Let's drag that out, and we're going to attach the A variable to that and put it back in place of where the A variable was. So now we should, for false and false, we should still get false, which we do. And now for true and false, according to our table, we should get false, which we do. And now let's try the one that should be true, which is false and true. And that is true. So we have verified our truth table. So let's look at another compound statement. Let's look at this statement, not A or A. So in this one, we have a compound statement, but we only have one input, A. So A can take the value true or false. We have an intermediate column, which is not A, and then we have our final column, not A or A. So this not A is going to be this red column, and then the A is going to be the purple column. So not A when A is true is false, and not A when A is false is true. So now we have in the last column false or true, which is true. And in the last row we have true or false, which is true. So any input to this statement, not A or A, is always going to be true. And there's a special word for that. It's called a tautology. A tautology is a compound truth statement that is always true. We can also build more complex compound truth statements with 3 or more truth values. So let's look at the compound statement A and B or C. So in this case we have 3 truth inputs. So we'll start off with 3 columns, A, B, and C. This time, instead of just having 4 possibilities, we will have 8 possibilities. And you can figure out how many rows you'll have by multiplying 2 to the power of how many inputs you have, in this case 3. So we have 2 to the 3 inputs, or 8 inputs. So we have true, 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 false, true, false, true, true, false, 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 true, true, false, true, false, 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 true, and false, false, false are our 8 combinations of input. In our second column, we'll have A and B, because we're trying to figure out this portion of the compound statement. So we're only looking at the first 2 columns for A and B. So for true and true, we have true, true and true, 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 false is false, true and false is false, false and true is false, false and true is false, and then we have all falses for the rest. So now we look at, for the last column, we're looking at the red column and the purple column. And I'm just going to draw an arrow. And I'm just going to draw an arrow and not rewrite that because it's pretty long. So we're looking at the red column and the purple column for an OR statement. So the first row we have true or true is true. And then false or true is true. True or false is true. False or false is false. Then we have true or false is true. False or false is false. True or false is true. And then false or false is false. So in this table we can make true 4 ways and false 4 ways. So it's half and half. And we can test this using Trinket as well, even though it's a little bit more complex. So we have A and B or C. So in Trinket, let's add a C. So go to variables, drag in a new variable, and make it C. And we're going to set that to a truth value. We're not using not A this time, so we can go ahead and get rid of that. And we're going to use another AND. So we want A and B. And we can put this entire block inside the other block. And switch this to OR. And then put in our variable C. So let's just test a few of them. We'll test all true first. So we would expect, judging from our truth table, all of these to be true. So our output should be true. And we do find that the output is true. Let's try a false one now. So on the truth table, if we have A is true, B is false, and C is false, then it should be false. So A true, B false, C false. And it's false. So it looks like our truth table is holding up.